Hello students, welcome to my channel Physics Nature. Today we will discuss about CBSE class 10th electricity chapter Ohm's law concept. This is very important for CBSE board point of view as well as NTSC competitive exam point of view. In the Ohm's law 1826, a German physics scientist George Simon Ohm by his experiments established a relationship between a relation between electric current by flowing through a conductor and potential difference V across its terminal. Okay, this is the relationship between the Ohm's law. The relation between electric current and potential difference across its terminals. This relationship is known as Ohm's law. And what is the statement? The statement is very important in exam point of view. The electric current I flowing through a conductor is directly proportional to potential difference V across its ends. Provided the temperature and other physical conditions of the conductor remains the same. And other physical quantities, the physical conditions like that pressure also, temperature and pressure, etc. And this is mathematically it is expressed as I is directly proportional to V, and this can also be written as V is directly proportional to I. V is equal to IR. Then R is equal to V by I. Here R is the proportionality constant. R is the constant of the conductor at a given temperature, and it is called resistance. R is the resistance. The resistance of a conductor is the property of the conductor due to which it resists the flow of electric charges. The resistance is nothing but to oppose the flow of electric charges. To oppose flow of electric charges. So mathematically, resistance of a conductor is given by the ratio of potential difference across a conductor to the current flow. That is R is equal to V by I, or V is equal to IR. Here V is the potential difference, I is the electric current, R is the resistance. So the current I is equal to V by R. It is obvious from the relation that the current is directly proportional to potential difference. The current is directly proportional to potential difference. If the potential difference across the ends of the conductor is doubled, the potential difference is doubled, the current I also doubled. If the potential across the ends of a conductor, the potential difference PD is half, then current also half. The next, the current is inversely proportional to the resistance. If the resistance is doubled, or is doubled, the current gets half. I is half. Then the resistance is half, the current gets doubled. Thus, the strength of electric current flowing in a given conductor depends upon two factors. Electric current is depend upon the strength of electric current depends on two factors. First one, potential difference across the ends of the conductor. Second one, resistance of the conductor. In this session already was discussed. The resistance is nothing but to resist flow of electric charges or to oppose the flow of electric charge. The SI unit of resistance SI unit of resistance, which is denoted by the symbol omega. Ohm. According to Ohm's law, resistance R is equal to V by I. V by I. Now, if the potential difference of V across two ends of a conductor is 1 volt and the current I through it is 1 ampere, then the resistance in the given equation will be 1 ohm. Therefore, 1 ohm is equal to 1 volt per 1 ampere. One ohm is the resistance of the conductor such that when a potential difference of 1 volt is applied to its ends, a current of 1 ampere flows through it. High resistance are measured in kilo ohm. The practical units of resistance: 1 kilo ohm, practical units of resistance, 1 kilo ohm is equal to 10 power 3 ohm or 1000 ohms. 1 mega ohm is equal to 10 power 6 ohm. The low resistance are measured in milli ohms. 1 milli ohm is equal to 10 power minus 3 ohm. 1 micro ohm is equal to 10 power minus 6 ohm. In this experimental, the verification of Ohm's law can also be verified experimentally. The constant ratio experimental verification. Ohm's law. The constant ratio is according to Ohm's law, R is equal to V by I. The constant ratio V by I gives the resistance R of the conductor nichrome wire in the experiment. So Ohm's law experiment can also be used to determine the resistance of a conductor. The slope of the straight line. So the straight line, the VI graph. I is acting along the x-axis because this is a independent variable. Potential difference V acting along the y-axis. The slope of the straight line on VI graph is delta V by delta I. Delta V by delta I, which gives the resistance R of the conductor. So therefore, R is equal to delta V by delta I. That is equal to slope of VI graph. Okay, in this one, for example, 2 points, let us consider 2 points A and B. Now how to measure is this is 1 point. Joining the 2 points, so delta V, delta I. Therefore, R is equal to delta V by delta I. So finally, in this one, Ohm's law, the relation between potential difference and electric current.